Prior to departure, there is fuel of 20,100 liter at a specific gravity of 0.78. Okay. You have to calculate traffic load. Performance limited takeoff mass, performance limited landing mass is given. Taxi fuel, trip fuel, contingency holding fuel, alternate fuel are also given to you. Takeoff column and landing mass column. In the takeoff mass column, you are going to write 62,800. In the landing mass column, you write landing mass limitation 54,200 and you add trip fuel, which is 9250. 54,200 plus 9250, 63,450. So now our takeoff mass will be, regulated takeoff mass will be the lower value. So lower value is 62,800. So this becomes a regulated takeoff mass. Step 2. Payload or traffic load will be equal to regulated takeoff mass minus DOM plus fuel on board. So 62,800 minus, what is DOM here? 34,930. Fuel on board or takeoff fuel. Now takeoff fuel will not include taxi fuel. Now first thing, 20,100 liter into specific gravity of 0.78. 20,100 into 0.78 is 15,678 kg. Okay, minus taxi fuel minus 250, give a value of 15,428. So fuel on board is 15,428. So 62,800 minus 50,358, 12,442. Option Bravo. Next, a twin engine aircraft is certified for a maximum structural takeoff mass 58,000. So takeoff mass limitation is 58,000. Landing mass limitation is 55,000. Performance limited takeoff mass is 61,000. So this is performance limited takeoff mass. This is maximum structural takeoff mass. This is maximum landing mass, and performance limited landing mass is what? Which is 54,000. So now as per rule, you are going to select any one value which is the lower one. Now between them 58,000 is the lower value. So write 58,000 as a limitation in the takeoff mass column. In the landing mass column, you are going to write 54,000 limitation. And in order to find takeoff mass, you are going to add trip fuel 36,000. So 54 plus 36 is 90. Next, we have to find what is the limiting takeoff mass for the aircraft. Okay, we do not have, okay, zero fuel mass is 36,000. So make the zero fuel mass column 36,000 plus takeoff fuel. Now takeoff fuel will be made up of trip fuel, alternate fuel, reserve fuel. Okay, so flight duration is 3 hours. So 36,000 plus 1,000 is 37,000. So 36 plus 37 is 73,000. So now we have to find out our takeoff mass value, our regulated takeoff mass value. It will be the lowest value. So the lowest value is what? 58,000. So this becomes a takeoff value. So correct answer is option alpha. Next. What is the maximum takeoff mass when structural limitations, landing, performance limitations and everything is given? Step 1. Takeoff mass column, landing mass column, zero fuel mass column. Takeoff mass column, write takeoff mass limitation which is 43,000. In the landing mass column, write landing mass limitation. Now we have two limitations, a structural and a performance limitation. Structural limitation is 35,000. Performance limitation is 33,000. So the lower value is 33,000. Write it here. Plus stiff fuel. What is stiff fuel here? 9,000. This will be equal to 33 plus 9,000 is 42,000. Zero fuel mass limitation is what? 31,000 plus fuel on board. Now total fuel capacity is 12,500. They are talking about capacity. But in reality, how much fuel have we loaded? 9,000 plus 1,000, 10,000. 10,000 plus 500, 10,500. 10,500 plus 400, 10,900. So write 10,900 here. So 31,000 plus 10,900 is 41,900. Okay. Next. So what is the maximum takeoff mass? So the lowest value here is 43,000, 42,000, 41,900. So it will be 41,900. But now 41,900 is not given in the question or in the options. The closest option here is 42,000. So we will select option Bravo. Okay. Next. The center of gravity of an aircraft is situated at 115.8 and mass is 4,750 kg. A weight of 160 kg is moved from a hold which is situated at 80 arm distance to a hold at 120 arm distance. What would be the new center of gravity? Arm. What would be the new center of gravity? Arm. So the formula is mass that is moved into distance that mass you have moved equal to total mass of aircraft multiplied by CG change in center of gravity. So how much mass have you moved? A weight of 160 kg is moved. So write 160. The distance you have moved this mass from 80 to a new distance of 120. So difference between them is 120 minus 80, 40. Total mass of aircraft is 4750 multiplied by x. CG change. Original CG is 115.8. We have to find out new CG. To find out new CG, we must first know x, which is 160 into 40 divided by 4750. So 160 into 40 divided by 4750, 1.3. Okay, this is the change in center of gravity. Now, original center of gravity is 115.8. Now, you are moving this new mass from forward position to the aft position. So, center of gravity will also move up. So, it will increase. New CG will be old CG 115.8 plus the change in center of gravity 1.3. That is 117.1. So option alpha is the right option. Next, an airplane has a tank capacity of 50,000 imperial gallons. It is loaded with the fuel to a quantity of 1,65,000 kg, 790 kilogram per meter cube. What is the specific gravity and how much fuel can be added? So specific gravity equals to mass of fuel in terms of kg divided by volume in terms of liters. Okay. Now currently it's given in the question, uh, volume is 790 kilogram per meter cube. Okay. 790 kilogram per meter cube. Now 1 meter cube equals to 0.001 liters. Okay. So 1,65,000 kg will be equal to how many liters? We will have to divide 1,65,000 by 790. Volume will be equal to 165,000 divided by 790. So that will be equal to 208.86 meter cube. Okay. Now this will be how many gallons? Number of gallons. This volume will be how many gallons? Volume divided by 0.001. So 208.86 divided by 0.001. So 208.86 0.001 is 208.860 liters. Okay, 208.860 liters. Specific gravity is mass on volume. So let's check this 165. That is 0.79 specific gravity. So correct answer is option delta. You need not solve the second part because if first part is right, second part will also be right. Calculate the amount of cargo that can be loaded given the following information using CAP 696 and all that. So we have been given performance limited landing mass, strip fuel, contingency fuel, alternate fuel, passengers, the baggage. So first let's find regulated takeoff mass. Now regulated takeoff mass will be performance limited landing mass plus strip fuel. What is the performance limited landing mass in this question? It's 55,000. Fuel is 9,700. 55,000 plus 9.7, 64.7. Traffic load will be equal to regulated takeoff mass minus DOM plus fuel on board. 64.7 minus DOM 34.9 plus fuel on board. Now what is the fuel on board or takeoff fuel? It's strip fuel plus contingency fuel plus alternate fuel, right? So what is strip fuel? 9,700, 1,200, 1,400. So total is 12,300. 9,700 plus 1,200 plus 1,400. 12,300. 300. So 64.7 minus 34.9 plus 12.3. That is 47.2. 17.5. 17,500. Now, what is payload given in the question? Payload means passengers and their baggage. So 130 passengers at 84 kg each is equal to 10,090, 920. And the baggage is equal to 130 bags into 14, 1,820. So 1,820. So 1820 plus 10,920 is 12,740. So now we all know traffic load equals to payload plus cargo. Now traffic load is 17.5, payload is 12.740, cargo is x. So x will be 17.5 minus 12.74, which is 4.76. So cargo that can be loaded is 4,760. The closest option here is option charge. This concludes the lecture. I hope you have understood all the questions that I have answered in this video lecture. If you have any questions, let me know in the comment box. Thank you.